The last type of isomers that we'll see is called functional group isomers. These kind of isomers, they have the same molecular formula but different functional groups. So they belong to different homologous series. So for example, if you look at this one, so C3H8O, so because it has only one oxygen, so we'll have to think about all the homologous series that we know. What homologous series have only one hydrogen? So it's only alcohols or ethers. And you could also have aldehydes or ketones, but the number of carbon would not match up if it's an aldehyde or a ketone. So here it can only be an alcohol or an ether. So 3 carbons, you can have 1, 2, 3, and then OH. Or you could have 1, let's put the oxygen at the center, and then the 2 carbons on the side. So that would be an ether and an alcohol. So here, if you would name this is 1 propanol, and this one, so this is a methyl group, this is an ethyl group. So we'll give the name starting with alphabetical order side chains first. So ethyl, methyl, ether. This is for the naming of ethers. I've seen in some responses that some of you have been trying to write like methoxy ethane or ethoxymethane. When you're naming ethers, for IB levels, don't use methoxy or ethoxy to name ethers. It's a simple nomenclature. You just name the side chain here and then name the side chain on the other side and then just put them in alphabetical order. So here, ethyl, methyl, ether. So you don't have to wonder whether it's going to be ethoxy or methoxy or epoxy. So just don't bother about the oxy in the name. For now, just name the 2 side chains and then just put them in alphabetical order for the naming of ethers. Now another example, C3H6O. So these can be aldehydes or ketones. So you can have a ketone with, so the oxygen is going to be in the center, of course. Here you have the ketone, or so this is propanone, or you could have propanol as the aldehyde. So these 2 are functional group isomers. This is a ketone, this is N, this is a ketone, this is an aldehyde. This is another isomer. Here you have 2 oxygens. So when you have 2 oxygens, generally it's esters or carboxylic acid. And esters and carboxylic acid are functional group isomers of each other. So see, for H8O2, so let's try to draw so carboxylic acid, let's say butanoic acid. And then for the ester, you can have ethyl ethanoate. Now, if you consider the ester, you could also have methyl propanoate or propyl methanoate as functional group isomers to butanoic acid. So any one of these 3 esters would be the functional group isomer of butanoic acid. So just to recap about functional group isomers, so it's just that it's different molecules having the same molecular formula but different functional groups. You need to know the functional group that are isomers to each other. You need to know that alcohols and ethers are possible functional group isomers, aldehydes and ketones, as well as carboxylic acid and esters. These are pairs that will be functional group isomers of each other. So you need to remember these. So coming back to structural isomers, IB questions may ask you to simply draw the structural isomers of a specified molecule. Then it's going to be up to you to see if it's going to have chain isomers, positional isomers, or functional group isomers. Sometimes the question will specify you need to give positional isomers or you need to give chain isomers, but sometimes it will not specify. It will just use the general term structural isomers. Then you will have to figure out which is going to be the more appropriate one for you to draw.